Now we're in fractions. We're going to first focus on chapter section 4.1, which is fraction introduction and mixed numbers. The numerator is the top number in a fraction. This tells us how many parts are being considered, how many parts of the whole. The denominator is the bottom number. This tells us how many parts are in the whole set. A proper fraction focuses on the numerator being less than the denominator. So the top is less than the bottom. So this is more of a common fraction that we may see. This is less than a whole or less than 1. So if I have 3/4 of a pizza, I only have maybe 3 slices out of 4. An improper fraction is a fraction whose numerator is equal to or even greater than the denominator. So this could be having a whole pizza, 4 out of 4 slices. Or if we have 5 out of 4, this can also be an improper fraction. Now, a fraction bar is dealing with the same as, so that little bar that's dividing the numerator from the denominator, that's the fraction bar, or the fraction bar. Now, this means the same thing as a division symbol. So as you can see in the little illustrations on the right of the definition. So that fraction bar is meaning the same as division. So here's a little practice. Write each quotient as a fraction and each fraction as a quotient. Okay, and then try and simplify, try and get the answer. Okay, so this would be written the same as 2/5. Okay, what about this? How would we write this as a division symbol? So I'd really like you to practice, try and write these out. I'll give you some time, or you can pause this and try and write this out and try and answer these on your own, maybe on a separate sheet of paper. Remember, please try and do the practice work. Don't just wait till Monday, but also you can go ahead and those terms that are on the first page, make index cards, study those terms. Okay, so we have 3 into 6, and we want to simplify it into 2. Okay, what about this? This is a division symbol. How can we write this as a fraction? 4/4, and we would simplify this as 1. Okay, try and do this fraction, the shaded. Okay, count the whole, count how many pieces make the whole. So that's going to be 5. There's 2 shaded. So 2 out of 5. I can't make it any smaller. I can't simplify it. What about this one? Okay, find the whole, find the shaded. 5/9. Can I simplify it? No. Okay, a fraction lowest terms. A fraction is in lowest terms when the greatest common factor, we're bringing in what we learned about greatest common factor, of the numerator and the denominator is 1. So I want to try and simplify this. I want to find the greatest common factor between the both of these. Now, what is the greatest common factor here? I know 3 can go into both, I know 7 can go into both of these. 3 times 7 is 21, and 5 times 7 is 35. So 7 could be my greatest common factor, but I have to write these out, think through it. I can do prime factorization. Okay, so 3 times 7, 5 times 7, that greatest common factor I'm going to go ahead and cross off. And then now I'm left with 3 over 5. So this is an easy way to use what we just learned to simplify these fractions. Okay, I'm going to show you some more practice ones. I want you to try and do these on your own using greatest common factor. So go ahead, pause this. Okay, 5 times 6, 6 times 9, 6 cancels out, so we're left with 5 over 9. Now, if I can make this smaller, that probably means I didn't use the greatest common factor. Okay. Okay, what about 9 and 14? Go ahead, pause that, see if you can find. And there was no greatest common factor, so it cannot be reduced. Okay, let's try these. Go ahead, pause. And you're just writing yes or no. But please show your work. Okay, so if the fraction is in lowest terms, we can't make this smaller. It would not have a greatest common factor. For B and D, we were able to find the greatest common factor. For B, 2, you can simplify this to 5 and 6. And then D, you can also simplify this. Okay, practice 5. Express 2 1/3 as an improper fraction. So basically what we're looking here is 2 would be, since we're looking at 1/3, if we had 1, it would be 3 over 3. Okay, now we have 2 1s, so 3 over 3 plus 3 over 3 is 6 over 3, plus 1/3, that would give us 7/3. So let's go ahead and we'll focus a little more on these improper fractions as well. Now I can also do 3 times 2, which is 6 plus 1. And that would still give me 7 over 3. Now, renaming a mixed number as an improper fraction. We're going to find the numerator of the improper fraction by multiplying the whole number by the denominator. And that's what I just described. And add the numerator of the fraction. We'll then place the numerator over the denominator of the fraction in the mixed number. So let's take a look at this. Okay. So we can try and do 12, okay, times 8 plus 3. So 12 times 8 is going to be 96, plus 3 would give me 99. So there we have 99 over 8. Okay, go ahead, pause this. Let's try and do these examples. Remember, you're doing 5 times 1 plus 3. Okay, show your work. We're going to multiply. Okay, that was awful quick, but if you can go back and check those, you can pause those. Equivalent fractions. Equivalent means equal to. So half equals to 2/4, which is the same as 3/6. However I write it, if I write even 4/8, that's the same as half. Now the identity property, we learned this before. Do you remember identity property? Okay, we learned about all those properties, commutative, associative. You can multiply mentally to fill in the blank. So basically, we're going to go ahead and kind of use, so we can kind of go backwards, because division is the opposite of multiplication. We can kind of do the same thing. We can check that work and we can kind of go backwards. So let's look at an example for equivalent fraction, focusing on the missing number. So if I have a missing number here, I'm either going to put an x here or an n. So 3/4 would be what? Okay, over 20. So let's see how we're going to do that. Okay, 4 times what equals 20? We know 4 times 5 equals 20, right? So that's what I can do with the 3. I will have to do, okay, the same number that I'm multiplying the 4 by. So 3 times 5 equals 15. 4 times 5 equals 20. So that n will be 15. Okay, let's go ahead, pause it. Let's try this one. You're doing maybe division now, or you can go work your way backwards. Okay, 5 times what equals 30, or 30 divided by what equals 5. So you're going to do the same thing with the 42. Okay, if you're doing 5 times 6 equals 30, okay, or 30 into 6, what's 42 into 6? Or what times 6 equals 42? Okay, 7. Okay, let's do another practice. Okay, you can go ahead and pause it. Are the following pairs equivalent fractions? Yes or no? Okay, are they equal? Okay, make sure you show your work. Okay, let's look at another practice. Find the missing denominator for these two examples, or numerator. Okay, go ahead, pause this and show your work. Okay, here's the answers. We can also do cross multiplication for this. Instead of going across like that, we can do something called cross multiplication. This is where I can do 3 times 20 equals 4 times n. And when I have 3 times 20 equals 4 times n, I want to get rid of that 4. And I want to get rid of that 4n, so I will divide both sides into 4, and then I will get n by itself. And then I have to divide 4 into 60, okay? So we'll do some practice on this in class on Monday before the textbook work if you have any questions about this. But let's do cross multiplication for this one, okay? So I do 10 times 5 is 50, and 2 times n, so 50 equals 2n. Now I have to divide, okay, the 2n into 2 because I want n by itself, okay? If I divide 2n by 2 to get n by itself, I also have to divide 50 by 2, okay? And then that leaves the n by itself is 25. Okay, 50 divided by 2 would be 25. Okay. Let's move into comparing and ordering fractions. This is the last section. If I'm going to compare these unlike fractions, they're not equal, they're not equivalent. You can rename them as equivalent fractions with a common denominator. This ties in the least common multiple. So we're using, okay, least common multiple, but we're going to focus on a least common denominator. So let's look at an example. Okay, which fraction is larger, 6/9 or 7/12? Well, what I can do is I can go ahead and find the least common multiple. Okay, I go ahead and on the left side, I'm going to find the least common multiple for 9 and 12. I'm just looking at the denominator. Okay, and remember, denominator meaning down. Okay, what we have here is the least common multiple is going to be 36. So if I change it to 36, I'm going to multiply 9 times 4 equals 36. And then I know 12 times 3 equals 36. So if I'm multiplying 9 times 4, I have to multiply the 6 times 4. So that brings me to 24 over 36. And then if I multiply 12 times 3 to get 36, I have to multiply the 7 times 3, and that would be 21. So because I found the least common multiple, I actually turn these fractions into, okay, a equivalent fraction. Okay, I put it out of 36. Okay, let's go ahead and let's do these. Here are some examples. Oh, that was really fast. And maybe you want to pause this because this little guy's going fast. Okay, so the answer's at the bottom, but you can go through and look at how we're doing. We have 39, we have 13. We want to find the least common denominator, least common multiple of 39 and 13. Once we find that, whatever 39, okay, into 39 and 32 both go into, oh, I'm sorry, 39, we can divide that into 1/13. So whatever we find 13 and 27 go into, that least common denominator, we're going to multiply it. So it's going to be 351, 13 times 27. And then for, let's see here, 27, we're going to multiply by 13 to get that number. And if we do that on the bottom, if we multiply 13 times 27, we have to multiply the top by 27. But remember, we're not multiplying the other fraction by 27. We're going to multiply whatever it takes to get that least common denominator. And that will be 2 times 13. Okay. Now we move into cross multiplying, okay, for comparing fractions. Remember, cross multiplying is 3 times 8 and 4 times 7. Okay, we have 24 is less than 28. Okay, so we can compare fractions by less than, greater than, or equal to. Okay, go ahead, pause this, see if you can figure out the comparison. Okay, let's go ahead and compare these using less than, greater than, or equal. You can pause this in just a second. Okay. Make sure you show your work. Okay, here's your answers. Now, this is the last part of the section, is creating a number line for unlike fractions. Now, if I have these two fractions, I'm going to compare them, but then I'm going to actually, oh, I want to go back, sorry. I want to go ahead and place these on a number line. So really I want to take and identify the parts. So if I have 2 out of 5, I want to make the number line into 5 parts. if I have 4 out of 8, I want to make it into 8 parts, but I can also simplify 4 out of 8 into, I can divide it by 4, so into half. So for 4 out of 8, instead of dividing into 8 parts now, I can divide it into 2 parts. So that's how I'm going to do the number line. I'm going to look at the denominator and I'm going to divide it into parts, into 5 parts, and then I'm going to put, or shade in or count 2 out of 5. So for the 4/8, I'm going to probably be easier to simplify, divide into 2 parts and do it 1 out of 2. Okay? And here we have an example at the bottom. Okay, here are some practice examples. Draw a number line for the following. Okay, 3/4. So you can see at the top, the yellow. Okay, I divide it into 4 parts. I'm going to shade it, or not really shade it, but count up to 3. Okay, that 3/4. Okay, 4/6. Okay, I'm going to make it into 6 parts and then mark it at 4. And then if I do 5/8, I'm going to go ahead and divide it into 8 parts and then mark it at 5. So which one is going to be bigger? Which one's going to be larger? Which one's going to be smaller? So if I look at this, I have 3/5. Okay, let's look at 3/5. Let's look at 4/6. Ooh, 4/6 is bigger. And then we have 5/8. Okay, 4/6 is bigger than 5/8, but 5/8 is bigger than 3/5 on the number line. Okay, and I made we have 4 separate number lines here. Okay, oh, and then 2/4. 2/4 would be the smallest. Okay, so we will do some practice. We'll do some worksheets on this on Tuesday, and we'll do some review. Now, if I have 3 2/3, I do want to go ahead and make it like 1, 2, 3, 4. Okay, I know it's between the 3 and 4 for the 3 part, but then I want to divide between the 3 and the 4 into 3 parts because we have 2/3, and then I mark that 2/3. So, okay, we're all done.